Hi, in this video we'll be going over how to configure DMVPN, which stands for Dynamic Multipoint Virtual Private Network. DMVPN is a multipoint GRE tunnel that allows for a hub-to-spoke setup. On top of our DMVPN, we will be configuring IPSEC and ISAKMP, and we'll be utilizing front door VRF. So here we have a hub connecting to 3 spokes. We are using 10.0 networks for our transport. That'll be our VRF BC. And we're using the 137.233 network for all of the backsides for the spokes, as well as the DMVPN tunnel itself. Our goal is to get all of our backsides to send traffic to the hub's tunnel interface over the 137 network. So first thing to configure is front door VRF, as well as all of our IP addressing, and then we'll go ahead and configure the IPSEC and ISAKMP, and lastly the DMVPN tunnel itself. Starting with the hub, go into global, start by setting up our VRF, IP VRF BC, exit, interface F00, no shut, F01, no shut, and F10, no shut. F00 is going to spoke 1. So link to spoke 1. And before you set an IP address on an interface that you're going to be putting in VRF, you first need to specify the VRF. So IP VRF forwarding BC. You'll get a message saying that, oh, well, before I did this, I already had set the IP address on it so that you can see what happens. That IP address is removed from the interface because that interface was switched over to the VRF routing table. So it erases it. So first you want to set up IP VRF forwarding, then go ahead and configure the IP address, which we are using 10.0.10.1. This is a /30, and that's it for F00. F01 is going to spoke 2. Spoke 2 also in VRF BC, and this is the 20.1. Next we have F10, which is connecting to spoke 3, VRF forwarding BC, and its IP address is 30.1. Okay, so if I do show IP route, I will not see any routes or interfaces in my routing table because I have not configured anything in my global routing table. But if I am to show IP route VRF BC, there I will find all of my interfaces that I just configured for VRF BC. So my router has 2 routing tables that it's utilizing: VRF BC for front door VRF, and my regular routing table for my inside VRF, which is just your default routing table. Okay, moving on to spoke 1. First thing is IP VRF BC. That creates the VRF. F00 going to the hub. We'll also put F00 in the BC VRF, so IP VRF forwarding BC, and then configure the IP address 10.0.10.2/30. exit. Now to test this connection, we'll ping VRF BC 10.0.10.1. VRF does not have usable source address. Show run. I have VRF BC. Oh, F00 forgot to no shut. So interface F00 no shut. There we go. Knew it was something simple. So let's try again. Ping VRF BC 10.0.10.1. And success. So I am pinging through my black core VRF. Okay. Let's go to spoke 2. Configure. Spoke 2 is using F01. So IP VRF BC. Exit. Interface F01. No shut. Description. Link to hub. IP address, IP VRF forwarding BC, IP address 10.0.20.2, 255.252. Exit, do ping VRF BC 10.0.20.1. There we go. But I will not be able to ping 10.1 yet. That should fail. Yes, because we are going to have to configure a routing protocol for our VRF. So let's go to spoke 3 first. IP VRF BC, exit. Spoke 3 is using F10 to connect to the hub. Description. Link to hub. IP VRF forwarding BC, IP address 10.0.30.2. There we go. Ping VRF BC 10.0.30.1. And I did it again. Configure T, interface F10, no shut. Exit. Exit. There we go. Now it should work. 10.0.30.1. Good. Jump back to the hub. We are going to use RIP for our VRF black core. And once we start configuring our 137 network, we'll be using eigrp. So let's go ahead and do router RIP version 2. And in order to use RIP for VRF, you have to specify that it's going to be for VRF. So address family, IPv4, VRF, BC. Network, the 10.0 network, and that should be it. You can exit address family. You don't have to. As soon as you exit out, it automatically sets that up for you. But this right here is how you set up RIP for a VRF. So if I do show run, go down to my protocols, I'll see where it says router RIP version 2, and then the address family that I'm using for VRF. So it has an exit address family in case I want to continue to configure RIP for my regular routing table. Address family IPv4 VRF BC shows the configurations specific for that VRF, and then it'll end that address family by showing you exit address family. But we're still just going to continue to use eigrp for our 137 network just to be safe, and so we can also show you how to set up 2 routing protocols. Okay, we have RIP set up on the hub. Spoke 1, router RIP, version 2, address family, IPv4, VRF BC, network, just like that. Spoke 2, router RIP, version 2, address family IPv4, VRF BC, network 10, and spoke 3. Network 10.0. Here we go. Now you don't have to type exit address family again. It's for me, I like to put the period on the end of the sentence, so to speak. Okay, so going to spoke 1, let's go ahead and show IP route VRF BC. And now in my spoke 1, I see the 10.30 network and the 10.20 network learned through RIP. So spoke 1 should be able to ping spoke 3, 30.2. Yes. Last thing that we want to set up for VRF is our loopback on the hub where our tunnel will be terminating. So interface loopback 0. Let's put a description on it. We'll just put let's see, DMVPN NBMA. Okay, and IP VRF forwarding BC, IP address, and we're using 10.0.40.1. And for this, we'll just use /24. Got it. Now that should also be in the routing table for the spokes, yes. And they should be able to ping the 40.1. So now my spokes can ping the hub's loopback address. Okay, now there are a lot of configurations along the way to setting all of this up. So I'll be constantly testing every configuration after I've set it up. That way I don't have to go back and find out what I missed, because there is a lot of places for error in this. So ping VRF BC 40.1, and then spoke 3 ping VRF BC. There we go. Just want to make sure everything's working correctly. All right, so that is how we set up our front door VRF and the routing for our front door VRF. Now we can begin configuring our DMVPN tunnel. We'll first create the DMVPN tunnel, ping across it, make sure it works. Since it is just a GRE tunnel, we can go ahead and configure it without IPSEC. Then we'll set up the IPSEC and set up our eigrp. So on the hub, we are going to interface tunnel 100, description DMVPN, let's see, IP address 137.23.130.1. We're using a /24 for our tunnel. Tunnel source, loopback 0. We do not configure a tunnel destination for DMVPN. Tunnel key 99. But we do have to specify how that tunnel is gonna reach the other side. So if we're using VRF, we have to tell the tunnel to refer to our VRF routing table. So tunnel VRF BC. You can only establish a tunnel if you can ping the other router first. You can't ping the other router from the regular routing table. So from the hub, if I just try to ping 10.0.10.2, which is spoke 1, it's going to fail because I'm not pinging through my VRF routing table, I'm just trying to ping from my default routing table. Okay, as soon as I try to ping through my VRF, it works. So the same with the tunnel. It has to specify that you're using the VRF to get to the other side. Okay, so let's go back to our tunnel. Actually, let's see what I have so far. I have the tunnel configurations, tunnel key, tunnel VRF, tunnel source. Now we need to set up our nhrp, IP nhrp, authentication 99, IP nhrp, network ID. We'll just use 99 again. No IP redirects, IP nhrp. Here's what's important. This is what makes it the hub. Map, multicast, dynamic. Okay, IP nhrp. Let's see, hold time 600. And let's see, IP nhrp. We'll do no IP split horizon eigrp 5864 for when we're ready to configure eigrp. Let's see, do show run. Let's look at our tunnel again. Okay, it's looking a little bit better. Still a couple more things we need to add to it. Tunnel mode, to specify that it is a multi-point tunnel, and then the tunnel protection once we configure our IPSEC. So let's go ahead and type tunnel mode, GRE, multi-point. Okay. That should be good for the hub so far. Let's go to the spoke. Okay. Interface tunnel 100. Description DMVPN. Tunnel source. My tunnel source on spoke 1 is F00. Tunnel key 99. Tunnel mode GRE multipoint. Let's see, IP address 137.233.130.2/24. Let's see, tunnel VRF BC. Okay, now the spokes do have a few different configurations from the hub. So first we'll do the ones that are the same, no IP redirects, IP nhrp authentication 99. Now these two have to match the hub, the authentication and the network ID. Let's see, IP nhrp network ID 99. Okay, now for the configurations that are different, IP nhrp map, and we need 2 IP addresses that we're going to map. So the hub, all it needs to specify is that it's using multicast and that it's learning its spokes dynamically. For the spokes though, they need to specify what the next hop server is. So the first address is going to be the next hop server address, which is 137.233.130.1, the hub's tunnel IP address. And that's got to be mapped to the hub's NBMA address, which is its loopback 0. So 10.0.40.1. So that tells the spoke that how it's going to get to 137.233.130.1 is by sending traffic to the 10.0.40.1. Okay. Now we need an IP nhrp map multicast, since we are using multicast for this, and the NBMA IP address again, 10.0.40.1. now we need IP nhrp NHS, and we need to let it know that 137.233.130.1 is the NHS. Okay. Let's see, do show run. Let's look at our tunnel. So I have IP nhrp authentication, IP nhrp network ID. I have map 137.233.130.1, 10.0.40.1, map multicast 10.0.40.1, IP nhrp NHS 137.233.130.1. Let's see, IP nhrp holdtime 600. Okay, tunnel source, tunnel mode, tunnel key, tunnel VRF. That should be good for now until we configure IPSEC. So end show IP interface brief. Tunnel should already be up. And let's see if I can ping 137.233.130.1. And yes, so our DMVPN tunnel is working for spoke 1 to hub. Let's get it working for spoke 2 and spoke 3, and then we'll move on to the crypto. Spoke 2, interface tunnel 100, DMVPN, IP address, 137.233.130.3. Tunnel mode, Jerry Multipoint. Tunnel source, I'm using F01. Tunnel VRF BC. Tunnel key 99. No IP redirects. IP authentication, nhrp authentication 99. IP nhrp network ID 99. IP nhrp hold time 600. nhrp map the NHS address 130.1 and the NBMA address 10.0.40.1. nhrp map multicast 10.0.40.1. IP nhrp NHS 130.1. Okay, let's see, let's do show run. Make sure we have everything in there. And I have the IP address, tunnel source, mode, key, VRF, and I have all of my NHRP configurations. Spoke 2 should be able to ping the hub 130.1, yes. And once I get it, once I set up eigrp, oh no, it can already ping, because it's all on a /24, it's all pinging within the same subnet. Yes, that's fine. But we'll still have to set up eigrp so that we can ping from backside to backside. So let's go to spoke 3, interface tunnel 100, DMVPN, .4, okay, tunnel mode, GRE multipoint, tunnel source, F10, tunnel key, 99, tunnel VRF BC, let's see, IP nhrp, authentication 99, IP nhrp NHS, network ID 99, no IP redirects. Let's see, IP nhrp map 137.233.130.1 10.0.40.1. Oh my gosh, oops. There we go. IP nhrp map multicast 10.0.40.1. IP nhrp nhs 137.233.130.1. Again, there's a lot of configurations. I'm always double checking myself. Let's see, I need one more nhrp, and that's going to be the whole time. I have my tunnel configurations. All right, so let's go ahead and do IP nhrp hold time 600, and should be able to ping across my DMVPN tunnel. 130.1, yes. Let's try to ping another spoke. Good. Okay. Let's see. Spoke 1. I am using interface F10 for the backside. So I'm just going to say LAN. Let's no shut it. Let's see, IP address 137.233. I'm using 129.254 / 24. Okay. Spoke 2. Interface, and these spoke 2 and spoke 3 are using F00 for their backsides. LAN. IP address 128. They all have /24s. No shut. Spoke 3. And 127.254. No shut. Okay. Now let's start with the hub for setting up eigrp. Router eigrp will use 5864. Network 137.233.130.0 for the DMVPN. /24. No auto summary. Passive interface default. And let's no passive interface tunnel 100. Okay, good. Spoke 1. Router eigrp 5864. Network 137.233.130.0 for the tunnel. Network 137.233. Already got an adjacency. 129.0 for the backside. Now the adjacency is going to drop really quick once I passive interface default, and then no passive interface tunnel 100. Adjacency will come back, and then no passive interface F10 for the backside. And let's not forget to do no auto summary. Okay. Same thing for the other spokes. Router EI 5864. Network 127.233.130.0 /24. Network 127.233.128.0. There we go. No auto summary. Passive interface default. No passive interface tunnel 100. No passive interface F00. Oops. There we go. Last one. Exit. Router eigrp 5864. The tunnel. Network. The backside. 0. No passive interface, tunnel 100. No passive interface, F00. Wonderful. Now, on the hub, show IP, eigrp neighbors. Good, I got 3 neighbors, what I expect, and I should be able to ping their backside interface, each one. So 129.254 spoke 1. 128.254 spoke 2, and 127 is spoke 3. Now we are traversing the VRF BC with a DMVPN tunnel from our hub to our spokes, pinging from the 137.233 network. Okay, so let's go ahead and look at our configuration really quick before we move on. On the hub, I have loopback specified for the terminal point for my DMVPN tunnel. That loopback is in VRF. It has to be in the same network as the transport network that we're using. I have my tunnel 100 for my DMVPN tunnel. The spokes use 3 specific configurations for DMVPN. The hub only needs to specify multicast dynamic. They have an authentication and a network ID. The hub also specifies no IP split horizon eigrp. Oh, and that's a misconfiguration. It's supposed to be 5864, and I put some odd number in there. So good thing I saw that. Let's interface tunnel 100 really quick, and let's type no IP split horizon 5864 for the correct ASN number. Oops. 5864. There we go. It's gonna resync. That's, oh, didn't get rid of the old one. Let's get rid of this really quickly. I wonder if I need to type default in front of it. Yes, that should default it back so that it's not in there. I don't want to neither enable it or just say no. I just want it to be gone. Okay, good. Okay, so there it has the tunnel configuration, and it's specifying VRF BC as its transport. We have F00, F01, and F10 going to our spokes, all belonging to VRF BC on the 10 network. I have router eigrp 5864 for my 137 network, and I have RIP with an address family for my VRF network. Okay. Now, sometimes the routers do act funny when you're constantly making changes to all these protocols, DMVPN, nhrp. They have to send a lot of queries to each other, and they have to register. So when you make these configurations, sometimes you throw them off. Sometimes you have to shut and no shut the tunnel or take it out and put it back in just to get it working again. So let's show IP eigrp neighbors to make sure that we still have everything there. And one last time, let's ping the backsides to make sure that everything is still good. And see, I can't ping 128.254, and I should be able to ping 128.254. What about 127? I can ping 127, but I can't ping 128.254. So when I made that change, I did something strange to it. So, and this is where a lot of network administrators make mistakes because they can't figure out why something changed, and they start changing configurations. One good troubleshooting technique to do is to quickly remove the configuration and put it back in and allow the router to resync with the hub. So one easy way to do it is just type no interface tunnel 100 to remove that tunnel, and then paste it right back into the router. Oops. Let's see. Do show IP eigrp neighbor. Okay, so let's see. Show run. Let's find out why I'm not getting an adjacency. Oh, well, yes. So once I deleted the tunnel interface, it took out the no passive interface in eigrp. So that is one thing you also have to remember when you do that. Router eigrp 5864, not 586. And let's no passive interface tunnel 100. There we go. And now we get our adjacency back. Now the hub should be able to ping 128.254. Good. So something to be mindful of when you're configuring DMVPN and you're troubleshooting. Not a bad technique to just take the tunnel out and put it right back in to see if that fixes your problem, especially when it's something that's similar to this that happens. Okay. So now we set up our front door VRF, we set up our DMVPN tunnel. We want to go ahead and configure IPSEC and ISAKMP. So first things first, crypto ISAKMP policy, authentication pre-share, encryption AES 256, group, and I'll choose 5. Crypto ISAKMP keep alive 60. Crypto IPSEC transform set, transform ESP AES 256, ESP SHA HMAC, mode transport, crypto IPSEC profile, set transform set, transform set PFS, group 5, crypto IPSEC security association replay window size 1024, and lastly crypto keyring, and we'll name this keyring let's see, IPSEC key, pre-shared address any, and the key we'll use 1 down, 2 down, shift 1 down, 2 down. Okay. Now we'll interface tunnel 100 and type tunnel protection IPSEC profile, the name of the profile, and shared. ISAKMP is on, and now you're gonna get an error because the other spokes need to have that tunnel protection in order for it to work. Okay. I'm gonna go ahead and do this quickly for my spokes by just copying and pasting this information into their running configuration. That'll be spoke 1, spoke 2, and spoke 3. Let's see. Okay, let's go ahead and interface tunnel 100 tunnel protection, IPSEC profile, profile shared. Go into spoke 3. Tunnel protection, IPSEC profile, the profile name, shared. ISAKMP turn on for all of our spokes. And let's check to see. Oh man. And we did not get our neighbors back yet. Okay. Let's first type no router EI 58654. Let's get rid of that odd one. Okay. So what I want to do is compare my crypto configurations from spoke 1 to the hub, since I copied just the spoke 1 configurations to spoke 2 and spoke 3, and they look exactly the same. So profile, let's make sure that I spelled that correctly. Profile tunnel protection, profile, lastly profile yes. So again, what we'll do is go to the hub this time, since Note 1 has established an adjacency to the hub. It must be nhrp doing what it's doing again, and no interface tunnel 100. ISAKMP is off. Put it back in. ISAKMP is on. Router eigrp 5864. No passive interface tunnel 100. See if that fixes our problem. Oh, I see what I did wrong. Okay, the crypto keyring IPSEC key, we need to reconfigure that so that it's specifying VRF. So crypto keyring, well, first, before you can even change it, it's not going to allow you to. First you have to delete it. So just like that. Okay. So let's actually go into all of our routers really quick. Delete those key rings. If you're wondering why I'm deleting those key rings, that's because the command that we input wasn't complete. I'll show you what I mean right now. Crypto keyring, okay, IPSEC key, and then VRF BC. That's important. Now, pre-shared address zeros key. Okay, 1 down, 2 down, shift 1 down, 2 down. Here we go. Let's go ahead and get that configuration, copy it over to our other routers, and that should solve our problem. Let's see. type that in there. There we go. And there we go. The hub is gaining its adjacencies. Do show run. Spoke 2 just got adjacency. And we can expect Spoke 3 to come up anytime. There it is. So now we have adjacency again. Okay. Sorry, that was my fault. Missed one little configuration right here on the crypto keyring, VRF BC. Because we are using VRF, you have to specify that in the crypto keyring. Okay. Show IP eigrp neighbors and verify one last time that I'm able to ping 129.254, 128.254, and 127.254. Okay. So there's the hub's crypto configuration, front door VRF, the loopback, the tunnel, its interfaces going to the spokes, put in VRF, eigrp for the 137 network, and RIP for our VRF network. So I can show IP route and expect to see only the 137 network, and I can show IP route VRF BC and see only the 10 network. So that's how you set up a IPSEC DMVPN tunnel over front door VRF.